Good day, sir. I am Midshipman Charles Alfonso Gil, and together with my group mates, we will tackle about blind pilotage. So, blind pilotage. Blind pilotage means the navigation of the ship through restricted waters in low visibility, with little or no recourse to the visual observation of objects outside the ship. So, the principal non-visual aid to navigation that enables this to be done is high-definition warning surface radar, but all available non-visual aids are employed. The organization to achieve this is called the Blind Pilotage Organization, comprising a BP team led by BP officer or BPO. So, assessment of the risk involved in a blind pilotage passage. So, although normally the accuracy of blind pilotage is such that ship can be taken to an open anchorage and anchored within 50 yards of the desired place, the degree of the risk involved, particularly in restricted waters, must be carefully assessed. Congestion due to other shipping. The consequences of a failure of radar or the other vital aids once the ship has been committed to her passage, and the number and quality of fixing marks must be taken into account. Parallel index technique. So the key to blind pilotage is the principle of the parallel index. The running of a parallel index line provides real-time information of the ship lateral position relative to the planned track. On the chart, a line is drawn from the edge of a radar conspicuous object parallel to the perpendicular distance or cross-index range. From the object to the track is then measured. The range strobe on the radar is set. The range strobe on the radar is then set to this range, and a solid chronograph line drawn on a display parallel to the planned course on a scale appropriate to the range in use. Position 1, 2, and 3 on the chart and radar display show the ship on track at various instances up to the time that the island is abeam to starboard. So position 4 and 5 show that the ship of track to port. The exact distance of track can be measured by dividers from the radar echo of the island to the nearest point of radar clearing ranges. So are similarly drawn to the maximum or minimum distances from the radar conspicuous objects to keep the ship clear from dangers. So these are drawn as broken lines.
Thank you, Midshipman Salkil. I am Midshipman Josephine Santia Saklaran, and these are the factors to be considered in blind pilotage. Okay, the degree of risk involved in restricted waters must be carefully assessed prior to entry. Bridge watches may be doubled up and watch level upgraded. Congestion through the other shipping should be considered. Both radars or ARPA should be operational. Consequences of failure of radar or other vital aids should be considered, and risk assessment should be done. The availability of navigational aid which can be used in restricted visibility must be taken into account. Raycons, AIS, voice or station, BTS, and etc. Parallel indexing can be used as a powerful tool for position monitoring and execution in passage. Draw one set of parallel index lines ahead of those in use. Plan the passage so as to steer a course to pass a given distance of a radar conspicuous point. Alter course of a navigation mark to point of land. Planning and execution of blind pilotage and anchorage. Parallel index technique. The key to blind pilotage is the principle of the parallel index. The running of the parallel index line provides real-time information on the ship's lateral position relative to the planned track. On the chart figure 1, a line is drawn from the edge of radar, conspicuous object parallel to the planned track. The chronograph parallel index line at the scale of the display. This can be made easier by constructing scales for each range setting, as shown below, and mounting them adjacent to the display. The crosses on the chart do not represent fixes and only appear in order to illustrate their example. Radar clearing ranges. Radar clearing ranges in figure 2 are similarly drawn at the maximum or minimum distances from the radar conspicuous object to keep the ship clear of danger. These are drawn as broken lines. Course alteration. Wheel over positions are calculated and plotted on the chart as for visual pilotage. A radar conspicuous mark is selected as close as possible to the wheel over position. A packed line is then drawn through the wheel over position in figure 2A, parallel to the new course and the course index range measured. This wheel over range is plotted on the display as spec line parallel to the new course. When the selected mark reaches this line, as the wheel should be put over and the ship brought around to the new course, by which time the mark should be on a firm line denoting the parallel index for the new course.
Thank you, Midshipman. I am Midshipman Neponte, and these are responsibilities during blind pilotage. In normal circumstances, the navigating officer is the pilot of the ship. Although, if he is not a navigation subspecialist, the duty of pilotage devolves on the captain, who may either perform it himself or at his discretion. Depute any officer of the ship's complement to do so, no matter what the blind pilotage organization may be the subspecialist navigating officer head is always the pilot of the ship, and thus he should also be the blind pilotage officer BPO. The conduct of blind pilotage. The navigating officer should remain on the bridge in poor visibility and conduct the blind pilotage from there. It is essential to have another officer who is suitable by training and experience as a blind safety officer, BSO, in the operations room where he can monitor the blind pilotage and back up the navigating officer on the bridge. The BSO will need to be in touch with the surface plot to assist with the identification of radar contacts. The navigating officer conducts pilotage from the bridge, regardless of visibility, building confidence in his team and command. In good visibility, the BSO checks the visual plan, while in marginal visibility, the bridge team uses visual information to supplement radar information. In nil visibility, the NO conducts blind pilotage from the bridge radar display, monitored by the BSO. If reports from the NO and BSO disagree, immediate action may be necessary until the position is accurately determined. The blind pilotage team must have sufficient flexibility to cope with the blind pilotage situations, considering navigational and collision avoidance information from various sources. General principles. To ensure success, ships must navigate accurately along a pre-arranged track using radar and other aids. In narrow waters and anchorage stages, working directly from the radar display with a prepared notebook is necessary for anti-collision and navigation. Regular fixing is necessary for safety and insurance. The following principles apply. The navigating officer should navigate the ship, while the captain should have easy access to the blind pilotage position and the NO. The ship should be coned from the compass platform, and all personnel should be briefed on the visual blind plan before passage. Navigational charts with the NO's prepared plan should be available on the bridge and operational room. Regular exercise in visual and blind techniques is crucial for confidence in the system. Good communication between the blind pilotage position and personnel is essential.
Thank you, Midshipman Riconte. I am Midshipman Serapion, and these are blind pilotage planning. Number 1. Normal planning considerations for selections of tracks apply. Blind and visual tracks should be the same to enable the transition from visual to blind or vice versa to be made at any time, and also to allow one plan to be used to cross-check the other. Number 2. The number of course alteration should be kept to a minimum to reduce the workload in redrawing parallel and wheel over lines. Number 3. Always try to have 2 parallel index lines where possible, one on each side of the track. This provides a check on a measurement mark indications and can reveal index or linearity errors. Number 4. Select radar conspicuous object for parallel index lines and fixing. Clearly mark on the chart and brief the assistant, avoiding fixing by radar range and bearing on a single mark. Number 5. The BPO should frequently switch to longer range scales and parallel index marks to maintain accuracy. Change should be pre-planned and marked in a notebook, and the stage of chart change should be carefully considered. Number 6. Tidal streams and currents should be worked out and noted for calculation of courses to steer and for the calculation of EP. This should be displayed on the chart and recorded in the notebook. Expected sounding, allowing for height of tide and calibration of echo sounder, should be noted for each leg. The possibility of being early or late should be also borne in mind. Number 8. All hazards along the track should be boxed in by clearing range and their cross-index ranges listed in the notebook. Number 11. The The notebook should contain the full plan, neatly and legibly, recorded in chronological order. Sketches of both chart and radar display can be a great assistance to the BPO in evaluating a picture. A suitable notebook layout supplementing as a guide to blind pilotage planning. Number 12. Tracks plotted for entering and leaving harbor should not appear in the same chart simultaneously. Otherwise, confusion will arise. Number 13. Clearing range should be simple, safe, and easily interpreted. And number 14. Object used for wheelover should be conspicuous, easily identifiable, and suitably located adjacent to the track.
Thank you, Midshipman Serapian, and this is Midshipman Jason Sarna. Like anchorage execution, this can be backed up by the range stroke, but reliance on the stroke alone is dangerous because the reference is not lost as soon as the stroke is required for any other measurement. The dead range of the point of the land ahead when anchoring is 2.3 cables. The distance to run to the anchorage position may be obtained by subtracting the dead range from the actual range of the point. For example, if the range of the point is 7.3 cables, the distance to the anchorage is 7.3 minus 2.3 is equals to 5 cables. The dead range of the point of the land starboard side when anchoring is 3 cables on the radar display. This point of land should move along the parallel index line drawn 2.5 cables to starboard of the approach track. When the ship reaches the let go position, the point of land should have reached point A, 3 cables beyond the beam position B. The distance AB equals the dead range 3 cables. Navigational records. When carrying out a blind pilotage passage, navigating officer or BPO will be too busy to maintain a continuous written record. It is essential that such record should be kept, and in comparatively unrestricted waters, it is normally sufficient for this record to be kept on the chart itself by plotting fixes and noting the position and time of alteration of course and speed and other relevant data. In addition to the record in the navigational record book. The procedure for navigation involves thorough chart work similar to pilotage passage. In restricted conditions, the navigating officer or BPO should record commentary to the captain on tape, which along with the chart, fixes, courses, and speed should be used for analysis. Horizontal display in operations room can prepare passage on overlay, but loss of tracking and additional marks is a drawback. Royal Navy horizontal display are not precise enough for accurate blind pilotage.
So that was the report of our group regarding blind pilotage. Thank you for watching and listening. Have a good day and God bless us all.